Okay, hello everyone. So welcome to this lecture on nonlinear simultaneous equations, okay, for Sec 3 A Math. Okay, so previously in Sec 2, you would have learned simultaneous equations, but however, they were linear. Okay, as you venture into A Math, we're looking at non-linear simultaneous equations. Okay, so as you continue to do more papers and more practices, okay, you will see that your simultaneous equations will have quadratic. Okay, you will see that it could possibly have logarithms as well, indices as well. Okay, so just be prepared for these types of niche simultaneous equations that you will see, okay, in A Math. Okay, so without further ado, let's look at the learning outcomes. As usual, I extracted this from the O-level syllabus document for A Math. Okay, so candidates are expected to solve simultaneous equations, two variables meaning x and y, okay, by substitution. Okay, so what is important here is substitution. Okay, you will have learned in E-Math, okay, in Sec 2, that elimination is the ideal way of solving for simultaneous equations. However, when you're looking at non-linear simultaneous equations, okay, more often than not, we will be using the technique of substitution. Okay, looking at this first point, this is a recap of what simultaneous equations are about. Okay, so the solutions of a pair of linear, okay, and or non-linear equations, okay, correspond to the coordinates of intersection points of the graph. Okay, so what this means is that when you have simultaneous linear equations, okay, you will have two straight lines that will intersect at a certain point, and this point here is the solution. Okay, your set of coordinates x and y. Okay, this will also apply to a case when it's non-linear, where it could be a line intersecting a curve. Okay, so let's do a recap on simultaneous linear equations. So it's always of this form. Okay, and why is it linear? It's because the powers of the variables here are power 1. That is why it's called linear. Okay, so just a quick recap. So there are a few methods of solving simultaneous linear equations. Elimination, this is important, okay, more so for E-Math. Okay, however, as you can see, I bolded substitution over here because substitution is very important. So I listed down a few foolproof steps that you can read through here in order to solve simultaneous non-linear equations. However, I'll be illustrating substitution using an example later in this video, okay? So just stay tuned for that. So step 1, we will use the linear equation to express one of the variables in terms of the other, basically making either x or y the subject of the equation. Then we will substitute that into the non-linear equation. This will isolate out one variable for us to solve, and therefore we can solve for one variable only. Okay, now of course, once we have the value of one variable, we will go on to find the value of the other unknown. The third step is, of course, there are graphical means to solve it by graphing out those two graphs. However, this is not the most feasible method in A Math. Okay, there is another method called the matrix method. Okay, this has been phased out of the syllabus a long time ago. Okay, that's why I struck it out there. Okay, now moving on to the content proper, okay, for A Math. For simultaneous nonlinear equations, okay, it is not of this form. Okay, it is not of this form where the power is power 1. Okay, so therefore, I will re-emphasize that the method most commonly used to solve is substitution. Now, this word has been used a lot in this video, so without further ado, let me illustrate this using an example here. So over here we have a pair, okay, of simultaneous equations, one of them being non-linear, okay, which is obviously this one. This is linear, this is non-linear. Okay, so in order to do this, I must use substitution. So I will look at this one, okay, because it is easier to make x or y the subject of the equation, right, for the second one. So with reference to that, I will make y the subject, okay, because it seems like it's easier, right? We just shift this over. So we will get y equals to 2x minus 2. Okay, I'm going to label this equation 1, and I'll label my nonlinear equation equation 2. So by substitution, what I'm going to do is I will plug 1 into 2. So I will say sub 1 into 2. Okay, so as you can see here, this whole y will replace this one over here. So it will be x squared plus 2x minus 2 bracket square equals to 8. Now of course over here we will expand, okay, using the a minus b bracket square. So a minus b bracket square is a square minus 2ab plus b square. Okay, so we will just do that, x square plus, okay, a square will be 4x square, then minus away 2 times 2x times 2, which will give a negative 8x, then plus 4, okay, 2 square. This equals to 8. Simplify the like terms, okay, so this will give us 5x squared minus 8x, okay, and then 4 minus 8 will be negative 4 equals 0. Okay, so over here I will solve for x, alright, this is easy, right? You have learned this in Sec 2, okay, on factorization. Okay, so what you can do is you can draw the table, or you can use your calculator, okay, your mode 3 in which you will get 5x plus 2 and x minus 2 equals to 0. Apply your zero product rule to give us 5x plus 2 or x minus 2 equals to 0. So x is equal to negative 2/5, okay, or x equals to 2. Okay, so you see I have two answers here. Then now that we have x, I can plug it back into equation 1, right? So I will sub it back into equation 1 to find my y. So y is 2 times minus 2/5 minus 2 to give us negative 14/5. And over here is y equals to 2 times 2 minus 2 equals to 2. Okay, so this is how you will solve, okay, a pair of non-linear simultaneous equations. Okay, this is what we call substitution. This method here is substitution. Okay, and what does x and y mean? Okay, this means that this curve intersect this line, okay, at 2 points, okay, and the coordinates are, okay, they did not ask us for coordinates this time, okay, but if they ask you to represent these solutions as coordinates, then it will just be minus 2/5 minus 14/5, and then you have 2 and 2. Okay, so essentially it is this curve will intersect the line at this point and this point. That is what these values mean. However, if we're just solving for them, okay, then you can just leave your answers as such. Okay, so this will conclude my lecture on nonlinear simultaneous equations.